Security Dave here. Today we're going to be talking about passwords. What is a password? What makes a good one? And how are they used? Alright, so let's dive right in and learn about passwords. So what is a password? A password is a secret word or phrase that must be used to gain admission to something. That's kind of an old definition of a password. You know, it's something like you'd say at the door to a secret club to get in. It's also used, the other definition is a string of characters that allows access to a computer system or service. This is probably more like what we'd see nowadays, or think of what we use it as nowadays. You know, it's your secret passphrase or password that you use to gain access to things like your email account or your Facebook account or your social media, that sort of thing. And on the screen here is an article from Wordfence, which is a great plugin for WordPress that talks about what passwords are, how they work, and how people crack passwords. I'll link to this article in the description of this video. But a good kind of intro is that there's different types of ways to authenticate or prove you are you to computer systems. And you can see here the top one there is something you know. So this is the example of your password. They also give you bank card pins. When you put your card, your checking account or your debit card into, say, like a charge terminal or an ATM or something like that, you have to prove that it's you holding the cards. You have to enter some kind of identification. So that's a pin. There's also other things, other combinations. If you've seen my other videos or watched any of them, you talk about multi-factor authentication all the time. Multi-factor authentication is the combination of multiple of these authentication methods. So something you know, which is typically what you first get prompted for when you're entering onto a website. You go to Gmail or Yahoo or something like that for your email. You type in your password, and then if you're on an unknown device, if you have multi-factor authentication set up, it'll prompt you for one of these other two. Something you have, which is oftentimes like a 6-digit code from an authentication app or something like that, or it may text you a number. Those are some of the multi-factor authentication ways. So something you have, it proves that you have the device in your hand. So if you have, say, a multi-factor authentication code set up on your phone that generates random numbers, it proves that you have the phone in your hand. The other thing is it texts to your phone number, and that will prove that you have the phone in your possession. The last one there is something you are. So this would be biometrics. If you have a fingerprint reader on your phone, or less common is something you have a less fingerprint reader on your car, on your computer, something like that. They also talk about retinal scans and things like that, but those are pretty uncommon as far as currently used, at least. They'll certainly get more common in the future. So that's what a password is. We can talk a little bit about how they're used. And I have a screen here. So it's from the same website. When you go to any website and you type in your password, say your password is Apple, which would be pretty horrible password. When you type this password into a website, the website should take that password, and if they're doing this correctly, they add what's called a salt. So this salt adds a second part to your password. It essentially extends it and adds a common. It should be randomized, but often adds an addition to your password that prevents people from cracking it. So what the website does is it takes these two pieces after it adds the salt and runs it through a hashing algorithm, which is a one-way function. This can only go one way. You can't take this hash over here and go back through the same algorithm to get back to your password. So a hashing algorithm will always give you the same length, depending on what algorithm they choose. It will give you a length of characters that are all like this. So it's 0 through 9 and A through F. So you're always going to get the output of this run through the same hashing algorithm or through one hashing algorithm is always going to be this output here. So now you can see in this down here, they store the hashed password plus the salt, which is what this additional extra piece is, and the salt itself, because they need to be able to know what the salt is to be able to run this algorithm again. When you come back in and enter your password again, it'll add the salt that they determine plus your password, run it through the hashing algorithm, and see if it matches this down here. So now, so there's a couple things here. First is when sites add this salt. This is very important because what hackers do is they take every password, say they have A and AA and AB and AC, and they run every single combination through these hashing algorithms to determine what the hash is of, say, A, and it's this. And AA is something just a little different, or well, they're always completely different. And then AB is something completely different, and AC is something completely different. And that's called a rainbow table. So what the hackers do is they generate these rainbow tables, and when data breaches come out, if the site doesn't use a salt, and in best case would be a randomized salt per password. If they don't use a salt, they can just these rainbow tables will tell them what the passwords are. Maybe this exact password right here, or this salt, this hash matches exactly to some predetermined hash from this rainbow table, and now they know that your password is AB. So that's why salts are important, because this computation takes a really long time to generate. If you took every combination of letters from AA to 200 characters down, or even 30 characters down, it's going to take a long time to generate all these. So now other ways that sites mess this up quite frequently is, at least maybe not quite so frequently as recently, but I've certainly seen examples of this, is where you say, oh, I forgot my password, and you enter your email address into the forgot password form, and it actually emails you your password. Like, your password is Apple. So now what the site is doing is storing your password in plain text. If you ever get your password back from a request for password, like what is my password, or I forgot my password, and they send you your password, they're not doing this at all. They're not hashing the password. They're certainly not adding salt, and they're just storing your password in plain text. So this is really bad practice, because what they're doing is compromising your password. If you use this password on other sites, you could certainly have no fault of your own. Say this website's compromised and they leak, they lose their database of passwords. Now the hackers have probably maybe your username or your email address if you log in with an email address, and some password, which is why it's extremely important never to use the same password across multiple sites ever. And this comes back to my other videos of password managers. It's extremely important to never reuse the same password because of this exact, this problem. It could be no fault of your own. Some website is compromised. Say they don't salt the password, and then somebody has a rainbow table for, say, this particular algorithm, and now somebody could run through this list and find, oh, this person's password is this person's password is this, so on and so on down the line. And then the hackers take these determined passwords and go over to website1.com, and they enter all these passwords into this website, and now they're what's called credential spraying or credential stuffing into this website to determine, maybe I can gain access to this website with these password usernames and passwords. And more oftentimes than not, they do, because people share same passwords across multiple websites. So we've talked about how, what they're used, how they're different, how websites use passwords, and how their specific salting and hashing and things like that can help protect your password. But how do you pick a good strong password? So, if we were to pick a good strong password, we'd probably want something that has, let's go by the typical guidance, right? The typical guidance is, you want to have an uppercase letter, you want to have, this would obviously be a really bad password, but an uppercase letter, a lowercase letter, a number. So let's do hello with 0. And then, you have to have symbols. So hello with an exclamation mark. So capital H, lowercase e, 110, exclamation mark. So that right there is what they claim is a strong password, right? It's got uppercase, it's got lowercase, it's got numbers, it's got a symbol. This is a terrible password. Really, you want to go for length. The most important thing in a password is length. So now, if you're, not using a password manager, which I strongly suggest because they will generate passwords that meet these criteria, and they're 30 characters long. You don't have to remember what the password is. If you don't want to remember your passwords, this is the perfect thing to do. I mean, most people forget their passwords. I'll say I'm occasionally one of those people who forgets their passwords to sites I don't really care too much about, but for those sites that I really do care about, say my bank or my email account, something like that, I generate 20 or 30 or 40 character passwords for these accounts. You just want to have it very long and very strong. Now, if you're generating passwords and you don't, you're not using a password manager for these kind of things, maybe you want to make a passphrase instead of a password. Say, like, I think my example I've used previously is my dog spot is awesome. Exclamation mark. You have a capital M. You have spaces. Now, there's a lot of websites out there that are really bad at passwords. They won't let you use spaces. You could certainly type this out without spaces, and it would be 2, 5, 9, 11, 12, 13, 14, 15, 16, 17, 18, 19 characters long. And with spaces, it gets to 20, 21, 22, 23 characters. So this is a really long, nice password. Now, I certainly wouldn't suggest that you use this on every single website. Maybe you change it. You talk about your cat or your lizard or your bird or your favorite pizza, something like that, and you go about creating passwords. Now, my suggestion, of course, again, is to skip this altogether and just use this super long password right here for your password manager. Like LastPass, which I have some videos on, and or KeyPass if you like local stuff that's not up in the cloud. I would suggest using this super strong password that you just made to encrypt or be your master password for these services. That would keep you'd only have to remember one super long password rather than a bunch, or sharing this super long password amongst multiple sites, which basically makes it useless anyway. All right, so I'll just skip over to an example tool to test super long passwords. It's called the GRC Haystack, and it's on grc.com. It's haystack.html, and you can type in various passwords. Like here, let me type in that my dog spot. My dog spot is awesome! Exclamation mark. Oh, it says, I don't have any digits. Okay, I'll add a digit, a 1, and then an exclamation mark. So it tells you how long it would take or how many characters are possible within this password. So it says here it's 24 characters long, which is about what we counted because we had the 1 extra there. It tells you that you're searching, if somebody was to try and guess every single possible combination, because you have an uppercase, a lowercase, a number, and a symbol, which is kind of the old guidance, it will be searching between 26 characters, which is uppercase, lowercase, numbers, and 33 different symbols, which is 95 different alphabets. So that's 95 different characters could be in each one of these individual spaces here. It's 24 characters long, so 24, I believe, you'd have 95 different characters in each one of those 24 spaces, which is this many different search space count. So, this is 2.95 times 10 to the 47th places. So there's a lot of numbers in here, right? Because it's 2 with 47 digits afterwards. So he gives you an idea of how long it would take to guess this password based on various types of guessing situations. Now, the fastest one is obviously going to be this one here, where it's like your password gets in the hands of the NSA, and they've got a huge supercomputer pounding away on it. But, this number is probably a lot lower now than it was previously, because it says they're assuming they're guessing 100 trillion guesses per second against your password. So, if you kept adding characters, the number keeps going up because you're adding more characters to your password and guess strength. Thank you for learning all about passwords. If you have a suggestion for video topics, please leave me a comment below or email me directly. If you like these videos, please like and subscribe my channel. Thanks again.